Section 7.3, Law of Cosines. Now, the first thing we're going to talk about here is just all of these equations here that we get for the law of cosines. Now, I just kind of want to point it out to you that we have to draw our triangles correctly in order to understand how all this works together. So if this is angle B is here, and angle C is here. We know the sides opposite those angles are the lowercase letters. So if I have A over here, opposite is going to be little a, and then this is going to be little b opposite big B, and then C, I'm going to have a little c over here. So this is our general setup for any of these problems here. So if I'm looking at this first one here, this one here, what we're looking at here is I know B and C, and possibly big A. So I'm going to know little b, little c, and I'm going to know big A. And then if I know those three things, I can use this first equation. Okay, so notice what I have to know. I have to know a side, an angle, and then the side next to it. So this is kind of the idea that we're going to use for the law of cosines. Now I'm going to give you a problem. Okay, so take a look at this problem here. So if I want to think about the law of sines here, there has to be a way that I can either find these angles out by using the sum of the angles equals 180 degrees, which I can't here, so I can't use that idea. Or I would have to know a side and an angle opposite the side. And if I look at all three of my possibilities here, I do not know a side and an angle opposite the side. I would have to know at least one pair. So if I had 55 degrees here, I would have to know what this side is right here to use the law of sines. Or if I had this 90 side here, the 90 meters or whatever it is, 90 units, I would have to know this angle A, which I don't. Or I would have to know, if I know this 100 side here, which is little c, I would have to know this angle here. So I'd have to be able to do that for any one of these pairs in order to use the law of sines. This is an indicator right away that I'm going to use the law of cosines. If I can't use the law of sines, I use the law of cosines. Okay, so let's get started with our problem now. So here we go. So I know this side over here is little b. Okay, and that's what we're going to find first. And the reason why I pick that is because I know little c and little a. Okay, and where do I know A and C at? If I look at this second one here, this is where I know A and C and B at. So that tells me right away I'll be able to use this one in order to solve this equation. So here's the setup. And if you need to pause this to kind of see where everything went, that's fine. But essentially, my A was here, and that was way over here. And then my C, which is here, goes there. Then I have an A in here, and then a C in here. Then on the end is my B, and that's what went inside of there. So there we go. So now we're just going to multiply what we can multiply, add what we can add. So first step, all the arithmetic gives me this. And again, like I said, you can pause it when you need to. And then now all I'm going to do is finish this up, and this is actually going to equal. So here's what it equals. So b squared equals 7775 point blah, blah, blah. Okay, and don't forget, now we have to square root both sides, okay, because we need to get a b. And then when we do that, this is what we get. We get 88.1794. Now in the book, most of the problems they do 3 sig figs, which simply means 3 non-zero digits, or 3 digits where at least the beginning and the end is not 0. So anyways, we end up with, for this problem, the approximation is going to be 88.2. Okay, so that's what our b equals. So now what we're going to do is we're going to find out angle A and angle C. So now to do those, we're just going to use the law of sines because now we have an angle and a side opposite the angle. So that's what we're going to do now. So here we go. Okay, now for the law of sines, I'm going to use the sine of 55 degrees over 88.2, and that's going to equal, I'll use side A here, so I'll have the 90 on the bottom, and then that means on the top I'm going to put the sine of A. So now all I'm going to do is a little bit of algebra to find out what the sine of A equals. So this would be our first step, and the sine of 55 degrees, I would get 90 times 0.8191 blah blah blah, and that's going to equal 88.2 sine of A. Now what I'm going to do is divide both sides by 88.2. That cancels there, or I should say reduces there to 1, and then I get on the left side. So then now I have to take the sine inverse of both sides. So really, I'm going to get on the left side A, and on the right side, it's going to be the sine inverse of 0.83586 blah blah blah, and then my A is actually going to equal 56.706 blah blah blah. Now again, we're going to round it to the 10th spot, which would be the 3 sig fig, and it's going to actually turn out to be for us 56.7 degrees. So that's going to be what our A is. Now we're just going to go through a similar process for the next one. So A is 0.7 degrees. So now we're going to find the next one, which is C. So here it is. Okay, so now we're just going to find C here. Now that we have A and B, we can find C. So I'm just going to use the same thing I used for the last one. So I'm going to have the sine of 55 degrees over 88.2, and that's going to equal, and again I'm trying to find angle C, so sine of C over 100, always the side opposite. Okay, so then from here I'm just going to do my algebra again. So now here it is. I kind of worked it all out for you. So I got the sine of C equals 0.09287, and then I'm going to sine inverse both sides. So C equals the sine inverse of 0.9287 blah blah blah, and that tells me C actually equals 68.2398 blah blah blah. And then when I'm rounding here, this is going to be 68.2 degrees. So that's going to be this last angle here, 68.2 degrees. So that is all of the sides of our triangle, and we just completed every side and every angle we didn't know. So that's it.